Okay, welcome America, welcome Selena Gomez and India to the live studio recording in 202 of pre-calculus. We are going to do two problems from the notes, from the day 3 notes that we've already seen, but I thought we should absolutely go over these again. And then we'll move on to the classwork once we're finished with these 2 videos. All right, so this concept, for whatever reason, is difficult every year because it has a weird name, average rate of change, okay? So the definition is at the top here. Find the average rate of change for each function. Up until now, when we're trying to find slope, right, we've always had a straight line, and we can see the steepness. How steep is the slope of the line? Average rate of change is the same, except for we've got curves now. So if I plot these, I just picked a couple points. If you plug in 0, of course you square it. 0 squared times 1/2 is still 0. If you plug in 1 squared is 1 times 1/2 is 1/2. That's where I got these points from by plugging it into f of x equals 1/2 x squared. So 0, 0, and I'm just kind of estimating on the graph here. Okay, so 1, 2, 3, 4, 5, 6. All right, so 1, 2, 3, 4, 5, 6, 7. We'll just go up to 8. Okay, so 1/2 is about right here. 2, 2, 2, 3, 4, 8. Okay, so you can see this is a quadratic, right? And I'll do that in red. And then 6, 18 is going to be up there, right? We'll need that for the second part of the problem. So when they ask to find the average rate of change from 2 to 4, what they're asking is 2 from this point to 4. 1, 2, 3, 4, when x is 4. 1, and then 4, 8 from this point. So if we were to take just back from Algebra 1 and use those 2 points and pretend like that's all we have here, and it's a straight line, and those are our points, pretend like that's a straight line, right? The average rate of change is just asking what's the slope in between those 2 points. So in Algebra 1, we do y2 minus y1 over x2 minus x1, and that's exactly what we're doing here. For the points, for the x values of 2 and 4, we'll start with, and it doesn't really, when you're doing slope and you have the 2 points, it doesn't really matter which point you start with, right? You could do y2 minus y1 over x2 minus x1, or you could do a y1 minus y2, but then you have to do x1 minus x2, right? You just have to be consistent with the numerator and the denominator. So if we start with the y, this is the y value for when x is 4, what is y? Okay, we already figured it out. When x is 4, y is 8. So f of 4, that's just an 8. So not really supposed to put an equal sign. We really should be working down, but of course we're running out of room. F of 4 is 8 minus f of 2, when x is 2, what is y? 2. 8 minus 2 over 4 minus 2. That's it. That's all we're doing. So we've got 6 over 2, which is 3. That is the slope of in between those 2 points. That's all it's asking. So for us to find the average rate of change now from 2 to 6, same thing. We're just doing f of 6 minus f of 2 over 6 minus 2. So I already figured out what f of 6 is. When I plug in 6, I get 6 times 6, 36. Half of that is 18. So when x is 6, y is 18. So f of 6 is 18 minus f of 2. When you plug in 2 for x, you get 2 for y. So f of 2 is 2. 6 minus 2, we'll just leave that as 4. So this 16 over 4, that slope is steeper. So I'll just use black, okay? So 2, 2 here, and then 6, 18 is way up here, right? We'll just, I don't know, pick it up there. You can tell that if you were to draw a straight line between those 2 points, it's gonna be more steep, it's gonna be steeper, the slope's gonna be greater. So the average rate of change is greater. That's it. Questions? Thanks for coming out.